Hello, let's talk about IV characteristics of a solar cell and different parameters associated with it. Welcome to Decreations Resources. We know that solar cell is basically a unit of solar energy generation system where electrical energy is extracted from the light energy. Now, we also know that the basic effect on which this working depends is the photovoltaic effect. So, solar cell is basically a semiconductor PN junction device. That means it is formed by joining P-type and N-type semiconductor material, where P-type, of course, has higher concentration of holes. It comes from a trivalent impurity doping, and N-type has a higher concentration of electrons. It comes from a pentavalent impurity doping. If you consider the p-n junction, there the movement of electrons to the p side is resulting into exposure of positive ion cores in n side, while the movement of holes to the n side is exposing negative ion cores in the p side. Now, this is going to result in an electric field at the junction, and basically a depletion region is going to be formed. Now, when sunlight falls on the solar cell, photons with energy greater than the band gap of the semiconductor are absorbed by the cell and they generate electron hole pair. These electron hole pairs migrate respectively to n side and p side of the p-n junction because there is electrostatic force of the field across the junction. So, basically, in this manner, a potential difference is established between two sides of the cell. Now, typically, a solar or photovoltaic cell has negative front contact and positive back contact. So, if you look at the diagram of a solar cell, you will see that there's a negative front contact assigned, there's a positive back contact assigned, and the p-n junction is sandwiched between that. So a semiconductor p-n junction is basically in the middle of these two. Now, if these two sides are connected by an external circuit, current will start flowing from positive to negative terminal of the solar cell. So this is the working principle for a solar cell. And of course, now we mentioned about band gap. If it's made up of silicon, the band gap at room temperature is 1.1 electron volt and the diffuse potential is 0.5 to 0.7 volt. So this is typically for a silicon solar cell. Now, for any electronic device, we try to look for its IV characteristic. So what is that? That is basically the superposition of the current versus voltage curves of the solar cell diode. And you can see, when you see that IV characteristics, there are certain parameters that are going to be important. These parameters can be determined from IV characteristics. Now, these parameters are namely the short circuit current, which is denoted as ISC, the open circuit voltage, which is denoted as VOC, the fill factor, which is called FF, and MPP, maximum power point, and also the efficiency. So, these parameters decide what rating the solar cell or the solar panel is going to get. Now, in the next segment, we will try to understand the meaning of all these parameters.